This is a line output transformer from a Bush TV22 that I've been restoring. The set was working fine, and then after about an hour it failed. The line output transformers, the primary is shorted out between the primary and the secondary, which is apparently quite a common thing to happen with these after a couple of hours of use. So I'm going to dismantle it and have a go at rewinding it. So before doing anything, make sure I've identified all the terminals correctly, and I've already dismantled this one previously actually, but I've labelled up all the actual wires from the windings, so I know which goes where before I take it to bits. This is one of the later ones, which has the straight laminations. As you can see, I previously treated this by removing all the pitch by dissolving it in white spirit and coating the overwind with transformer lacquer. And this one has the porcelain former for the rectifier overwind as well. So it should come to it quite easily. That just pulls off. And there's some packing inside, and then the overwind just slides off the primary, and that's what's underneath. It's in a fairly sorry state. It's all very thin paper between the windings, and the theory is, you see, there's some corrosion on the laminations, which has caused them to swell a bit, and probably what's happened is that's expanded and caused some stress to the windings, so that's caused them to fail. So before so what I'm going to do is very carefully unwind this layer by layer, and make a note of how many turns there are per layer, so I can and the dimensions and everything, so I can basically get everything back the way it started, because I believe these are quite sensitive to having the right inductance and capacitance and everything, so I need to make sure it goes back as close as possible to what it is now. So to help me unwind this primary coil and also to rewind it, I've got a couple of stepper motors here which I'm going to control from an Arduino with this CNC shield. One of them can be used to rotate the coil, and the other one with this lead screw to traverse the wire when I come to rewind it. So to unwind it, I'm just going to use the stepper motor really just to keep count of the turns, so that I don't lose track of how many turns of wire there are on here. So I can do it in a controlled way and keep track of what's there. So I've written a dead simple program on the Arduino that will just every time I press this button, it will do one revolution of the coil. And if I keep my finger on the button, it will keep doing one revolution after another. And on the screen I can keep count. So I can keep count of how many turns I've taken off and I can do that for each layer, and keep a note of how many turns there are on each layer of the coil. Okay, I'm 395 turns into the first of the coils. You can see how thin the paper is between these layers. It's really thin. So I'm keeping track of the number of turns on each layer. So that's the running count, and then that's the difference. So it's quite hard to tell exactly where one layer ends and the next finishes, but even so, I think there's obviously a bit of variation. I mean, the first layer wasn't a full layer anyway, but then these two, there's a bit of difference between the number of turns. So whether this was done on an automatic winding machine, I don't know. I would have assumed that we'd get it a bit more accurate than that. So I got to the end of the first winding. I'm on 1041 turns. You can see there that the number of turns per layer is around about between 150 and 160. I guess when they wound this thing, they had to stop the machine at the end of each layer to put the tape on, which probably explains why there's a bit of variation between layers in terms of the number of turns. Yeah, I'm getting towards the end of the primary winding now. I've just checked again the resistance between the primary and the secondary, and I'm still seeing about 60 ohms. So whatever the fault was, it's still there. So as I get towards the end, I'll try and keep a close eye. See if I can find out where it actually failed. I reckon the fault's going to probably lie at the end somewhere. It looks a bit, you can't probably see on the video, it looks a bit manky to me, where the paper's eroded away and the windings have been exposed. I'm guessing that's probably where the failures occurred, but we'll see. Yeah, so I've just got to the end of the first layer of winding A, which is the second of the primary windings, and the resistance between the primary and the secondary has increased from 60 to 150 ohms, so I'm guessing there was a partial short just at the end of that layer, but it's not cleared completely yet. So I'm getting towards the end of the second layer of winding A, and the fault's cleared between the primary and the secondary, so it must have been somewhere along this second layer, which kind of disproves my theory that it's happening at the ends. It must have been somewhere else. And that's the end of the primary winding, so the fault's definitely gone now. So that's all the winding off the core. There doesn't appear to be any damage to the Paxilin former at all, so I don't think it was the laminations corroding that's caused the problem. I think if Bush had just put an extra few layers of paper between the primary and the secondary, that probably would have got away with it.